Jean-Baptiste Pierre-Antoine de Monet, Chevalier de Lamarck, often known simply as Lamarck, was a French naturalist. He was a soldier, biologist, academic, and an early proponent of the idea that evolution occurred and proceeded in accordance with natural laws. He gave the term biology a broader meaning by coining the term for special sciences: chemistry, meteorology, geology, and botany. Zoology. Lamarck fought in the Pomeranian War with Prussia, and was awarded a commission for bravery on the battlefield. At his post in Monaco, Lamarck became interested in natural history and resolved to study medicine. He retired from the army after being injured in 1766, and returned to his medical studies. Lamarck developed a particular interest in botany, and later, after he published a 3-volume work Flore Françoise, he gained membership of the French Academy of Sciences in 1779. Lamarck became involved in the Jardin des Plantes and was appointed to the chair of botany in 1788. When the Muséum National d'Histoire Naturelle was founded in 1793, Lamarck was appointed as a professor of zoology. In 1801, he published Système des animaux sans vertébrés, a major work on the classification of invertebrates, a term he coined. In an 1802 publication, he became one of the first to use the term biology in its modern sense. Lamarck continued his work as a premier authority on invertebrate zoology. He is remembered, at least in malacology, as a taxonomist of considerable stature. In the modern era, Lamarck is widely remembered for a theory of inheritance of acquired characteristics, called soft inheritance. Lamarck has a more use-disuse theory, which he described in his 1809 Philosophie zoologium. However, his idea of soft inheritance was, perhaps, a reflection of the wisdom of the time accepted by many natural historians. Lamarck's contribution to evolutionary theory consisted of the first truly cohesive theory of evolution, in which an alchemical complexifying force drove organisms up a ladder of complexity, and a second environmental force adapted them to local environments through use and disuse of characteristics, differentiating them from other organisms. Scientists have debated whether advances in the field of transgenerational epigenetics mean that Lamarck was to an extent correct, or not. Biography. Jean-Baptiste Lamarck was born in Bazentin, Picardy, northern France, as the 11th child in an impoverished aristocratic family. Male members of the Lamarck family had traditionally served in the French army. Lamarck's eldest brother was killed in combat at the siege of Bergen-op-Zoom, and 2 other brothers were still in service when Lamarck was in his teenage years. Yielding to the wishes of his father, Lamarck enrolled in a Jesuit college in Amiens in the late 1750s. Lamarck showed great physical courage on the battlefield in the Pomeranian War with Prussia, and he was even nominated for the lieutenancy. Lamarck's company was left exposed to the direct artillery fire of their enemies, and was quickly reduced to just 14 men, with no officers. One of the men suggested that the puny 17-year-old volunteer should assume command and order a withdrawal from the field, but although Lamarck accepted command, he insisted they remain where they had been posted until relieved. When the colonel reached the remains of their company, this display of courage and loyalty impressed him so much that Lamarck was promoted to officer on the spot. However, when one of his comrades playfully lifted him by the head, he sustained an inflammation in the lymphatic glands of the neck, and he was sent to Paris to receive treatment. He underwent a complicated operation, and continued his treatment for a year. He was awarded a commission and settled at his post in Monaco. It was there that he encountered Traité des plantes usuelles, a botany book by James Francis Chommel. With a reduced pension of only 400 francs a year, Lamarck resolved to pursue a profession. He attempted to study medicine, and supported himself by working in a bank office. Lamarck studied medicine for 4 years, but gave it up under his elder brother's persuasion. He was interested in botany, especially after his visits to the Jardin du Roi, and he became a student under Bernard de Jussieu, a notable French naturalist. Under Jussieu, Lamarck spent 10 years studying French flora. After his studies, in 1778, he published some of his observations and results in a 3-volume work, entitled Flore Françoise. Lamarck's work was respected by many scholars, and it launched him into prominence in French science. On August 8, 1778, Lamarck married Marie-Anne Rosalie Delaporte. Georges-Louis Leclerc, Comte de Buffon, one of the top French scientists of the day, mentored Lamarck, and helped him gain membership to the French Academy of Sciences in 1779 and a commission as a royal botanist in 1781, in which he traveled to foreign botanical gardens and museums. Lamarck's first son, André, was born on April 22, 1781, and he made his colleague André Thoan the child's godfather. In his 2 years of travel, Lamarck collected rare plants that were not available in the royal garden, and also other objects of natural history, such as minerals and ores, that were not found in French museums. On January 7, 1786, his second son, Antoine, was born, and Lamarck chose Antoine Laurent de Jussieu, Bernard de Jussieu's nephew, as the boy's godfather. On April 21 of the following year, Charles René, Lamarck's third son, was born. René Louis Desfontaines, a professor of botany at the Royal Garden, was the boy's godfather, and Lamarck's elder sister, Marie-Charlotte Pelagie de Monet, was the godmother. In 1788, Buffon's successor at the position of intendant of the Royal Garden, Charles-Claude Flahaut de la Billarderie, Comte d'Angevilla, created a position for Lamarck, with a yearly salary of 1,000 francs, as the keeper of the herbarium of the Royal Garden. In 1790, at the height of the French Revolution, Lamarck changed the name of the Royal Garden from Jardin du Roi to Jardin des Plantes, a name that did not imply such a close association with King Louis XVI. Lamarck had worked as the keeper of the herbarium for 5 years before he was appointed curator and professor of invertebrate zoology at the Muséum National d'Histoire Naturelle in 1793. During his time at the herbarium, Lamarck's wife gave birth to 3 more children before dying on September 27, 1792. With the official title of Professeur d'Histoire Naturelle des Insectes et des Vers, Lamarck received a salary of nearly 2,500 francs per year. The following year, on October 9, he married Charlotte Reverdy, who was 30 years his junior. On September 26, 1794, Lamarck was appointed to serve as secretary of the Assembly of Professors for the museum for a period of 1 year. In 1797, Charlotte died, and he married Julie Mallet the following year. She died in 1819. In his first 6 years as professor, Lamarck published only 1 paper, in 1798, on the influence of the Moon on the Earth's atmosphere. Lamarck began as an essentialist who believed species were unchanging. However, after working on the mollusks of the Paris Basin, he grew convinced that transmutation or change in the nature of a species occurred over time. He set out to develop an explanation, and on the 11th of May 1800, he presented a lecture at the Muséum National d'Histoire Naturelle in which he first outlined his newly developing ideas about evolution. In 1801, he published Système des animaux sans vertébrés, a major work on the classification of invertebrates. In the work, he introduced definitions of natural groups among invertebrates. He categorized echinoderms, arachnids, crustaceans and annelids, which he separated from the old taxon for worms known as verms. Lamarck was the first to separate arachnids from insects in classification, and he moved crustaceans into a separate class from insects. In 1802, Lamarck published Hydrogeology, and became one of the first to use the term biology in its modern sense. In hydrogeology, Lamarck advocated a steady-state geology based on a strict uniformitarianism. He argued that global currents tended to flow from east to west, and continents eroded on their eastern borders, with the material carried across to be deposited on the western borders. Thus, the Earth's continents marched steadily westward around the globe. That year, he also published Recherches sur l'organisation des corps vivants, in which he drew out his theory on evolution. He believed that all life was organized in a vertical chain, with gradation between the lowest forms and the highest forms of life, thus demonstrating a path to progressive developments in nature. In his own work, Lamarck had favored the then more traditional theory based on the classical four elements. During Lamarck's lifetime he became controversial, attacking the more enlightened chemistry proposed by Lavoisier. He also came into conflict with the widely respected paleontologist Georges Cuvier, who was not a supporter of evolution. According to Peter J. Bowler, Cuvier ridiculed Lamarck's theory of transformation and defended the fixity of species. According to Martin J. S. Rudwick, Cuvier was clearly hostile to the materialistic overtones of current transformist theorizing. But it does not necessarily follow that he regarded species origin as supernatural. Certainly he was careful to use neutral language to refer to the causes of the origins of new forms of life, and even of man. Lamarck gradually turned blind and died in Paris on December 18, 1829. When he died, his family was so poor they had to apply to the Academy for financial assistance. Lamarck was buried in a common grave of the Montparnasse Cemetery for just 5 years, according to the grant obtained from relatives. Later the body was dug up along with other remains and was lost. Lamarck's books and the contents of his home were sold at auction, and his body was buried in a temporary lime pit. After his death, Cuvier used the forum of a eulogy to denigrate Lamarck. Cuvier's Eloge of Lamarck is one of the most deprecatory and chillingly partisan biographies I have ever read, though he was supposedly writing respectful comments in the old tradition of de mortuis nil nisi bonum. Gould, 1993. Lamarckian evolution. Lamarck stressed two main themes in his biological work. The first was that the environment gives rise to changes in animals. He cited examples of blindness in moles, the presence of teeth in mammals and the absence of teeth in birds as evidence of this principle. The second principle was that life was structured in an orderly manner and that many different parts of all bodies make it possible for the organic movements of animals. Although he was not the first thinker to advocate organic evolution, he was the first to develop a truly coherent evolutionary theory. He outlined his theories regarding evolution first in his Floreal lecture of 1800, and then in 3 later published works: Recherches sur l'organisation des corps vivants, 1802, Philosophie zoologium, 1809, Histoire naturelle des animaux sans vertebres. Lamarck employed several mechanisms as drivers of evolution, drawn from the common knowledge of his day and from his own belief in chemistry pre-Lavoisier. He used these mechanisms to explain the two forces he saw as comprising evolution: a force driving animals from simple to complex forms, and a force adapting animals to their local environments and differentiating them from each other. He believed that these forces must be explained as a necessary consequence of basic physical principles, favoring a materialistic attitude toward biology. Le pouvoir de la vie. The complexifying force. Lamarck referred to a tendency for organisms to become more complex, moving up a ladder of progress. He referred to this phenomenon as le pouvoir de la vie, or la force qui tend sans cesse à composer l'organisation. Lamarck believed in the ongoing spontaneous generation of simple living organisms through action on physical matter by a material life force. Lamarck ran against the modern chemistry promoted by Lavoisier, preferring to embrace a more traditional alchemical view of the elements. His influence primarily by earth, air, fire and water. He asserted that once living organisms form, the movements of fluids in living organisms naturally drove them to evolve toward ever greater levels of complexity. The rapid motion of fluids will etch canals between delicate tissues. Soon the flow will begin to vary, leading to the emergence of distinct organs. Histoire naturelle des animaux sans vertebres, 1815. He argued that organisms thus moved from simple to complex in a steady, predictable way based on the fundamental physical principles of alchemy. In this view, simple organisms never disappeared because they were constantly being created by spontaneous generation in what has been described as a steady state biology. Lamarck saw spontaneous generation as being ongoing, with the simple organisms thus created being transmuted over time, becoming more complex. He is sometimes regarded as believing in a teleological process where organisms became more perfect as they evolved, though as a materialist, he emphasized that these forces must originate necessarily from underlying physical principles. According to the paleontologist Henry Fairfield Osborn, Lamarck denied, absolutely, the existence of any perfecting tendency in nature, and regarded evolution as the final necessary effect of surrounding conditions on life. Charles Colston Gillespie, a historian of science, has written, "Life is a purely physical phenomenon in Lamarck." His views should not be confused with the vitalist school of thought. L'influence des circonstances. The adaptive force. The second component of Lamarck's theory of evolution was the adaptation of organisms to their environment. This could move organisms upward from the ladder of progress into new and distinct forms with local adaptations. It could also drive organisms into evolutionary blind alleys, where the organism became so finely adapted that no further change could occur. Lamarck argued that this adaptive force was powered by the interaction of organisms with their environment, by the use and disuse of certain characteristics. First law. In every animal which has not passed the limit of its development, a more frequent and continuous use of any organ gradually strengthens, develops and enlarges that organ, and gives it a power proportional to the length of time it has been so used, while the permanent disuse of any organ imperceptibly weakens and deteriorates it, and progressively diminishes its functional capacity, until it finally disappears. This first law says little except an exaggerated generalization of the belief that exercise develops an organ. Second law. All the acquisitions or losses wrought by nature on individuals, through the influence of the environment in which their race has long been placed, and hence through the influence of the predominant use or permanent disuse of any organ, all these are preserved by reproduction to the new individuals which arise, provided that the acquired modifications are common to both sexes, or at least to the individuals which produce the young. The last clause of this law introduces what is now called soft inheritance. The second law was widely accepted at the time, but has been decisively rejected by modern genetics. However, in the field of epigenetics, there is growing evidence that soft inheritance plays a part in the changing of some organisms' phenotype. It leaves the DNA unaltered but affects DNA by preventing the expression of genes. Some epigenetic changes, such as the methylation of genes, alter the likelihood of DNA transcription and can be produced by changes in behavior and environment. Many epigenetic changes are themselves heritable to a degree. Thus, while DNA itself is not directly altered by the environment and behavior except through selection, the relationship of the genotype to the phenotype can be altered, even across generations, by experience within the lifetime of an individual. This has led to calls for biology to reconsider Lamarckian processes in evolution in light of modern advances in molecular biology. Religious views. In his book Philosophiae Zoologium, Lamarck referred to God as the sublime author of nature. Lamarck's religious views are examined in the book Lamarck, the Founder of Evolution by Alpheus Packard. According to Packard, from Lamarck's writings he may be regarded as a deist. The philosopher of biology Michael Ruse described Lamarck as believing in God as an unmoved mover, creator of the world and its laws, who refuses to intervene miraculously in his creation. Biographer James Moore described Lamarck as a thoroughgoing deist. The historian Jacques Roger has written, Lamarck was a materialist to the extent that he did not consider it necessary to have recourse to any spiritual principle.